Algebra 2, Target 3, Day 2. I can solve a system of linear equations and interpret their solution. Yesterday, we looked at solving equations graphically. Finding the points, see where the two lines cross, and then plugging and chugging to see if they're correct. Today we're going to review two other methods, the substitution method and the elimination method. We're going to start with substitution. And to do substitution, you're going to take one of the equations and solve for one of the variables. It is best to look for a variable that's easy to solve, typically one that has a coefficient of positive 1. Once you've done that, you're going to take that equation and plug it into the other equation. Very important you use the other equation, otherwise you're going to get an inconsistent system or a dependent system. All right? Plug it into the other equation and solve. You'll get one answer or one variable solved for, then you plug it into the other and solve for that one. All right, so let's look at a substitution example. We got 2x plus 5y equals negative 5 and x plus 3y equals 3. We'll start by noticing that in the second equation, the coefficient on x is positive 1. That means it's really easy to solve for x. So that's what I'm going to do. I'm going to solve the first equation for x. And that's quite simply subtract 3y. X equals 3 minus 3y. Now that I have done that, what I want to do is I want to take this value of x right here, put it into the other equation in place of that value of x right there. All I've done is I took x out and put in another expression for x. By doing that, though, taking 2x, rewriting it as 2 times 3 minus 3y, plus 5y, equals negative 5. By doing that, I have rewritten that first equation in one variable instead of two. So now I can just solve that equation for one variable. We'll distribute 6 minus 6y plus 5y equals negative 5. Combine like terms, 6 minus y equals negative 5. We'll subtract 6 from both sides. We got negative y equals negative 11, or y equals 11. All right, now I want to take that y and plug it into any equation. It doesn't matter which one here. I can plug it in right here, or even I can go over to this equation and plug it in. And in fact, that's what I'm going to do. I'm going to plug it into that equation because I'm looking for x, and that one's explicitly solved for x. So I'm going to plug in y equals 11, x equals 3 minus 3 times 11. That's x equals 3 minus 33, so x equals negative 30. So my ordered pair solution is xy equals negative 30, 11. And of course, we want to double check. 2 times negative 30 plus 5 times 11, that's negative 60 plus 55, that works out to negative 5. That one checks out. Second equation, x is negative 30 plus 3 times y is 11, that's negative 30 plus 33, that's 3. That checks out. All right. So our ordered pair, that works as a solution. Moving on to the next method, the elimination method. This is typically set up in standard form. You got your x's stacked on top of each other, your y's stacked up on top of each other, your equal signs stacked up, and your constants stacked up in the two equations. Generally, ax plus by equals c. What you're going to do is you're going to multiply one of the equations by a constant in order to obtain what I call a matchup. There are two variables that have the exact same coefficient in front of them or exact opposite coefficients. Like if one's 5, one's negative 5. Once you have a matchup, you're going to add or subtract that matchup along with the rest of the equations to eliminate it. That will solve to a single variable. Then you'll plug and chug to find the other variable. So let's look at an example. All right, we have 3x minus 7y equals 10 and 6x minus 8y equals 8. As we take a look, we'll see that the x's are pretty close. Pretty close. I could probably have a matchup there if I doubled the first equation. That would change the 3 into 6. So I'm going to do that. I'm going to take the first equation, I'm going to double it. Whenever you double one side, you double the other so that you keep your balance. We'll double that, we'll get 6x minus 14y equals 20. The second equation, I don't need to do anything, and it'll still have the matchup. So I'm going to leave that equation alone and do 6x minus 8y equals 8. Now I want to add or subtract to eliminate. And you're going to have to look, and you have to do a little thinking here. What will cause my matchup to eliminate? If I add, will the x's go away? Well, no. 6 plus 6 is 12. They're actually getting bigger. So how about if I subtract? If I subtract, will they go away? 6 minus 6 is 0. Well, yes, they will. So I'm going to subtract. I need to subtract the whole thing. I can't just do it with bits and pieces. Whenever I do an operation, I have to do the whole problem. So I'm going to subtract these two equations. 6 minus 6 is 0 and is eliminated. Negative 14 minus negative 8y. Well, that's a double negative, so it's really negative 14y plus 6 plus 8y, which is negative 6y equals 20 minus 8 is 12. We'll divide by negative 6, and y equals negative 2. All right, y equals negative 2. So now I can plug and chug y into one of my equations to find x. And again, it doesn't matter, once you've found one of your variables, it doesn't matter where you plug into. I can plug into here, this equation here. I can plug into this original equation there, or I can plug into these equations that have been doctored. Right? It doesn't matter. I like to focus on the original equations. That way, if I made a mistake while doctoring, it'll show up when I check it. So I'm going to plug into one of the original equations. I'm going to use 3x minus 7y equals 10. And I'm going to plug in negative 2. So 3x minus 7 times negative 2 equals 10. That's a double negative, so 3x plus 14 equals 10. We'll subtract 14. 3x equals negative 4. So x equals negative 4/3, giving us an ordered pair of xy equals negative 4/3, negative 2. And of course, we're going to want to do ourselves a little check. So we got 3 times negative 4/3 minus 7 times negative 2. That should work out to 10. Let's double check those cancel. I got negative 4. That's a double negative. I got positive 14. Well, yes, that's 10. That one checks. Okay, so 6 times negative 4/3 minus 8 times negative 2. Okay, the 6 and the 3 reduce. Gives me negative 8 there, plus 16. Well, yeah, that's 8. All right, so that is my solution. The ordered pair, negative 4/3 and 2. Now, sometimes when you're working, you're not going to be told what method to use. So you need to be able to look at an equation and say, okay, in this case, it's probably better to use substitution, and in this case, it's probably better to use elimination. Well, what you want to do is you want to look. Substitution is convenient when one of the variables has a coefficient of 1 or negative 1. Right? So if one of your coefficients is 1 or negative 1 on any one of the variables, substitution is usually more convenient and quicker and easier to do. Otherwise, you should use elimination. Both methods will always work. Some methods will be easier in some cases. All right, so we're going to look at a couple more examples. We're going to say, okay, what should I use here? And then we're going to solve it. All right, so in example A, as we take a look, What should we use here? Well, we should use substitution because x has a coefficient of 1. Pause this video, use substitution, solve it, and then we'll check it. All right, so what we're going to do now is we're going to solve A using substitution. So I'm going to add 2y to both sides. I get x equals 2y plus 4. I will substitute that. 3 times 2y plus 4 minus 6y equals 8. We will distribute. We got 6y plus 4 minus 6y equals 8. All right, now notice 6y minus 6y is 0. I got 4 equals 8. All right, this is a trick question. Right, what happened here? Our variables fell out. I got a false statement. All right, let's take a look at the original question again. Let's use elimination on this one and see what happens. How would I create a matchup? All right, well, I would create a matchup by maybe tripling the first equation. If I triple the first equation, what happens? 3x minus 6y equals 12. And the second equation we'll keep alone, 3x minus 6y equals 8. Well, I got the same expression on both equations on the left side, but on the right side they're equal to two different things. What is it when they're equal to two different things? Well, our system has no solutions. So if you're working through, your variables fall out and you have an incorrect statement, 4 is not equal to 8, you have a solution with no system, no solutions. Let's try the next one, see what happens here. What would be easier here? Well, nothing's got a coefficient of 1, so it's going to be elimination. So pause, try and eliminate, see what happens. All right, so to eliminate, I would probably start by multiplying the top one, and this is going to sound a little mean or tricky, but the top one by 1/2, since they're all even, and the bottom one by 1/7. It is okay to use fractions. And it's just kind of like dividing. So the top one by 1/2 will give me 2x minus 5y equals 4. And the bottom by 1/7 will give me negative 2x plus 5y equals negative 4. What eliminates, addition or subtraction? Well, we can look and we can see, we can add, because they got opposite signs, and that'll get them out. Then we see that 0 equals 0. Well, what happened here? Well, all our variables fell out, and I get a true statement. 0 does equal 0, today and every day. Well, if everything fell out and we had a false statement leads to no solutions, when everything falls out and we end up with a true statement, we're going to get infinite solutions. So our ordered pairs are infinite. There are an infinite number of solutions where those two lines cross because they are the same line. So in conclusion, we have two methods for solving systems. We got the substitution method and the elimination method. If you have an expression that's easy to solve for x or y, you should use the substitution method. Otherwise, you should use the elimination method where you try to create a matchup and then add or subtract to eliminate the variables.